Hello and welcome to SOURAV Sir's classes. Today we'll talk about amicable numbers, or rather we'll talk about a little bit of friendship. Let's say the numbers 284 and the number 220. Now suppose you want to factorize these numbers. So what you do, you factorize these numbers, and what do you get? You get 1, 2, 4, 5, 10, 11, 20, 22, 44, 55, 110. These are all the factors of 220. Now 284's factors are 1, 2, 4, 71 and 142. Now let's suppose we want to add these factors together. So we will add all these factors together, and let's say for 220 the factors add up to 1 plus 2 plus 4 plus 5 plus 10 plus 11 plus 20 plus 22 plus 44. Just let me drop that out. 22, 44 plus 55 plus 110. Now this adds up to 284, and the sum of the factors of 284 are 1 plus 2 plus 4 plus 71 plus 142, which adds up to 220. So these two numbers are really friendly to each other and are called amicable numbers. Amicable numbers. Right. So to define amicable numbers, we write, this is the definition. Sorry, the pen's not working properly. Right. I hope you guys can make that out. A pair of numbers with the property that each is equal to the sum of the positive divisors of the other, including 1. Right. So a pair of numbers with the property that each is equal to the sum of the positive divisors of the other, including 1. So here we have the sum of the divisors or the factors, and here we have the sum of the divisor factors of 284, and these add up to 220 and 284 respectively. Now, how do we generate amicable numbers? The generation of amicable numbers. Now, the amicable numbers was first discovered by an Arab mathematician called al-Banna in the late 13th century. Let me just rub that out and write that proper. The late 13th century, and there was immense amount of research that went into this, and we can now find, for example, if n is a positive integer, that is z plus, such that 3 into 2 to the power n minus 1 and 3 into 2 to the power n plus 1 minus 1 and 3 squared into 2 to the power 2n plus 1 minus 1 are all prime, then 2 to the power n plus 1 into 3 into 2 to the power n minus 1 and multiplied by 3 into 2 to the power n plus 1 minus 1 and 2 to the power n plus 1 into 3 squared into 2 to the power 2n plus 1 minus 1. These two form what is known as an amicable pair. So this is not the only way to generate amicable numbers. There are many such ways, but this is probably the most that you can visualize properly. For example, if you just plug in 1, 2, you can just check if these are amicable or not. For example, if you plug in n equals 1, you get what is called a Pythagoras pair. Let's put an apostrophe, and n equal to 3, you get what is called a Fermat's pair. So even though there is extended research on amicable numbers, we still do not know whether the unanswered questions are they exist infinitely in pairs, there exist odd pairs of amicable numbers like 12,285 and 14,595 or 67,095 and 71,145, but it is not known whether there is a number where one is odd and the other is even. We do not know if such pairs exist. It is not known whether the pairs of relatively prime amicable numbers, let me just write that down, relatively prime amicable numbers exist or not. We do not know these. So we now know there are more than 600 pairs of amicable numbers, but we do not know if they exist infinitely. We welcome mathematicians and computer scientists to try it out. That's it for the video. Thanks for watching.